Hi everybody. Today I'm doing a comparison of the Victron SmartSolar charge controller with the EPEVER tracer charge controller. So I recently got some additional panels and I needed an additional charge controller, and this time I got a Victron, and the reason for this, given the Victron was 3 times more expensive than the EPEVER, was that I had to tweak the EPEVER settings low in order to prevent my LiTime batteries from having voltage surges. There would be voltage surges, and this would shut off the BMS of the battery. It would shut off the inverter. It would temporarily turn off the charge controllers, and I was able to get settings low enough on what the EPEVER's settings were, what they called boost voltage. If I lowered that to 27.5 volts, I could prevent the voltage surges, and that wouldn't happen. But my concern with leaving it like that was that the batteries have a BMS which requires 14.2 volts minimum per battery to have the BMS regulate or balance the cells. And I know from my RC flying, where I use lithium polymer batteries, that if you don't keep the cells balanced, eventually you'll kill the battery. So, these batteries aren't cheap. And, I've been running them for a few months with just the EPEVER controllers, and they seem okay, but I have no way of accessing the cells. I have no way of knowing, how unbalanced the cells are getting. And if that gets too far out of whack, it can, again, kill the battery. You could disconnect everything and periodically connect it to a charger, external charger, and use that to periodically balance the cells. But that seemed like, extremely inconvenient. So I was hoping that by getting the Victron controller, that this one would be able to raise the voltage to the minimum of 14.2, which in my case is 28.4, because my battery bank is set as a 24 volt bank. So I needed to get it to 28.4 minimum in order to have the battery's BMS balance the cells when it was in absorption mode. So I did this. I connected it to the system, and it worked. This was able to hold the voltage at 28.4 and hold it for the 2-hour absorption time, and not create any voltage surge and power interruption from the inverter, charge controller, or battery BMS. So what I've currently got running is I'm using the EPEVER chargers, but their voltages, their boost voltage is set at 20 7.5, but the bulk and absorption voltage here is set for 28.4, and which is the default setting. In fact, I just used the default for lithium iron phosphate here, and it's just worked fine. I haven't had to touch it. And so these two are working fine. These controllers, when they're set low enough, the 27.5 volts, they will not trigger the overvoltage condition. And this one will allow it, when the batteries are full, to take it up a little higher to the 28.4 volts to allow the absorption cycle and the balancing of the battery cells. I also compared the power produced from one of my EPEVER charge controllers compared with the Victron charge controller, and as far as I can tell, they're the same. In other words, although this thing responds quicker and prevents the voltage surges, I didn't notice a measurable increase in power production. Now, to be fair, I just tested it by looking at what the real-time, watching the real-time current produced by the charge controllers, each one connected to 4 panels, 2 series of connected in parallel. So there were 8 panels, 4 panels on each charge controller, the same exact configuration, and they produce the same exact voltage. So don't expect to be producing a lot more power with the more expensive Victron controller. But again, at least it allows me to raise the voltage to the level where the battery BMS will balance the cells. Now, on these, it's nice that they have that little LED indicator for bulk absorption and float, because you can't see that on these controllers this way. You would have to use either the a Bluetooth or a PC cable or something adapter to look at it under software in order to see this state of charge, whether it was in boost or float. This one you can just look at it. Also, this one has Bluetooth built into it, and so with that, you know, connected to your smartphone, you can get information. Another nice thing about this is the moment I connected it to my smartphone, it automatically downloaded and installed the current firmware and software, so it updated everything automatically, whereas I haven't really figured out a good way to get updated software on these yet. So for me, the current setup is working okay. You know, I'm not going to replace my 2 existing EPEVER controllers at this point. They're working well, and when used in conjunction with the Victron controller, I solved my problem with the voltage spikes. And so, you know, for those of you who are, you know, pondering, you know, is it worth the money? Which one should I go with? All I can say is it depends. Depends on what how your system's configured, what your batteries are. I guess, you know, how their BMS is going to work, how high a voltage it requires to balance the cells, and will that trigger the voltage surges. I think it also depends on the inverter. Some inverters probably are less sensitive to those voltage surges. I don't know. I guess every system's a little different. But this is what happened with my system, and I'm sharing the information, hoping that others can find it useful. Thanks for watching.